I put the link to the website where I downloaded the PDF file. Let's start. Number 1. For this type of questions, it is important that you check one thing first, and that is whether the graph of this equation intersects the x-axis, like this. If the graph is above the x-axis or below the x-axis entirely, then we will get either no real answers or an infinite number of answers. To check whether the equation has real solutions, we have to use the discriminant, which is b squared minus 4ac. The answer that we get is greater than 0. That means that we have two real solutions somewhere, which means that the graph cuts through the x-axis twice. Let's try to factorize this equation then. We have to use the quadratic formula. And because the solutions have roots in them, we can't tell what values they evaluate to. So let's try to get some rough estimates of these solutions. So first of all, root 21 must be between root 25 and root 16, which is 4 and 5. So we can say that root 21 is 4 point something. So for convenience's sake, let's assume that root 21 is 4. And between 0.5 and 4.5, there must be 4 integers. 1, 2, 3, 4. So the answer is 4 integers. The next question, number 2. It looks like we can factorize what's inside the roots. So let's factorize first. So that's done, but we have to keep in mind the range of a, -1 and 2. This must be a positive number, and this number also has to be a positive number. But if we use this rule and take a-2 out of the square root, we get the wrong answer. Because if we substitute a equals -1, we get a negative answer, even though we saw earlier each part of this expression must be positive. So in order to avoid this problem, we have to put a minus before the second pair of brackets. We can cancel out a, and we get a constant 3, and this is the answer. Number 3. So when you look at this equation, you may be tempted to solve this equation for x, but that's going to be really difficult, if not impossible. So we have to think of another way to do this. So what I'm going to do is to square both sides of this equation. And these numbers in the middle term can be cancelled out. So we get this. And all that's left to do is to move the constant to the other side. And notice that the left-hand side is identical to the left-hand side of this equation. So the answer is 18. And we basically have to do the same for the second question, except we have to cube both sides of this equation instead of squaring them. And you should notice that inside of these brackets must be equal to 4. And these two will cancel out. So the answer must be 76. The next question, number 4. Let's move the second term to the right-hand side first. And because we need the same base, let's change base 9 to base 3. And to do that, we have to use the change of base rule. And because 9 is equal to 3 squared, the denominator becomes 2. We multiply both sides by 2. The rest should be easy. We can basically get rid of the logarithm. So the answer must be 5. The next question. When we know the lengths of all the sides as well as one angle, we can use the cosine rule, which is c squared equals x is a, x minus 2 is b, and x plus 2 is c. Let's do some substitutions. Let's expand the square brackets. And cosine of 120 degrees is minus 1/2. We can change the signs and get rid of these. X times x, x times minus 2. And let's see if we can cancel out any of the terms. It looks like we can get rid of the constants. Okay. Let's take out 2 from each term and then factorize. So the roots are 0 and positive 5, but because x must be greater than 0, the answer we want must be x equals 5. The next question, this is weird. 4-digit numbers are made using the digits 0 to 4, where each digit is different. How many 4-digit numbers are there? And how many 4-digit odd numbers are there? Okay, let's name each digit. A, B, C, D. Okay, we need 4-digit numbers, so A cannot be 0, so A can be 1, 2, 3, or 4. B can be 0, or any of the numbers that were not chosen for A. Let's say X, Y, Z. And C can be any of the leftovers, X, Y, Z. And D can be any of the leftovers, X, Y. So we have 4 times 4 times 3 times 2, 96. The next question, we want 4-digit odd numbers, so D must be 1 or 3. A cannot be 0. Between 1 and 3, whichever was not chosen for D can be chosen, or 2 or 4. For B, any of the leftovers, so X, Y, or 0. And for C, any of the leftovers, X, Y. So 3 times 3 times 2 times 2, which is 36. And next we have a very weird pair of questions. There could be some clever tricks to solve these questions quickly, but let's just brute force these questions. 55. I'm sure most people can square 11, 12, and 13. And let's just add them up. This is the answer. Number 8. I gave these two expressions random names, vector u and vector v. We need 2 vector a and 3 vector b, so let's do some scalar multiplications. 2 times minus 1, 2 times 2, 3 times 1, 3 times x. And let's add the x components. Minus 2 plus 3, 1. 4 plus 3x, 3x plus 4. So these are the components of vector u. Let's move on to vector v. Vector a remains the same. plus minus 2 times 1 minus 2 times x minus 1 plus minus 2 minus 3, 2 plus minus 2x plus 2. The easiest method that I can think of is to multiply the x and the y component of vector u by minus 3. Minus 3 minus 9x minus 12. And the y components must be equal in order for vector u and vector b to be parallel, because vector u is going 3 steps in this direction and then however many steps this is. And this is vector u, and vector v must be doing the same. Since we kept the horizontal movement constant, the vertical movement must also be the same. So we only need to solve this new equation. We now know that x is minus 2. Question 9. Let f of x equal this and let g of x equal this. If f of x equals g of x, then find the possible values of x. Let f of x be equal to g of x. Thankfully, we can factorize. We flip the signs and we get 1 and minus 2. These are the x coordinates of the intersections of the two functions. Number 2, the coordinate of the vertex point of the parabola y equals f of x is, to find the vertex, we can use the formula for the x coordinate of the vertex. So the x coordinate of the vertex is minus 1 and the y coordinate is minus 2. The equation of the tangent to the parabola at the point 0 and f of 0 is this. Point 0 and f of 0. So let's substitute x equals 0 minus 1. Let's differentiate f of x. F dash of x, 2x plus 2. Let's substitute x equals 0 and we get 2. So 2 is the slope of the tangent at point P. And because P is on the y-axis, we know that the y-intercept is minus 1. So the equation of the tangent at point B is 2x minus 1. Number 4. The area bounded by the parabola y equals f of x and the line y equals g of x. Let's draw a very rough sketch of these two functions. So we basically have to find the area shown in red. But because this area crosses the x-axis, what I'm going to do is to lift everything up so that the area will no longer be under the x-axis. To do so, I'm going to add plus 2 to these functions. And finally, let's integrate. The straight line is above the parabola, so the straight line must come before the parabola. And we subtract the area under the parabola. And the answer must be 9 over 2. Section 2. The circle O is an inscribed circle of triangle ABC, and points P, Q, R are the points of tangency of sides BC, CA, and AB, respectively. AB equals AC equals 13, BC equals 10. Number 1. Find the length of AR. So first of all, we know the length of BP, which is half the length of BC, 5. So BP is 5, which means BR is also 5. So the length of AR must be 13 minus 5, which is 8. Find sine AOR. Because we know two angles, if we can find the length of AO, we can use the sine rule. So let's try to find the length of AO. The angle APB must be 90 degrees. So we can use the Pythagorean theorem to find the length of AP. AP is 12. And then we can use the fact that APB and ARO are similar triangles, so we can find the ratio 12 to 8, which is 3 to 2. So 3 to 2 equals AB and AO correspond to each other, and we know the length of AB, 13. And let's solve this. The length of AO is 26 over 3. And finally, we can use sine rule. Sine AOR is opposite to AR, so 8 equals sine 90 degrees. And sine 90 degrees is 1. And let's rearrange this equation. So the final answer is 12 over 13. Find the value of tangent AOR. So tangent AOR would be AR over OR. So we only need to find the length of OR, which happens to be the radius of the circle. To find the radius, OP is the same as OR because both are radii, and this is equal to AP, this length, minus AO, and we know both AP and AO. AP is equal to 12 and AO is equal to 26 over 3, which is 10 over 3. So tangent AOR would be 12 over 5. And we have already found the radius of the circle, which was 10 over 3. Number 5, the scalar product of two vectors, vector AB dot vector AO and vector AB dot vector BC. So vector AB is going from A to B. Let's consider the horizontal movement first. To go from A to B, we have to go 5 units this way, minus 5, and then go down 12 units, minus 12. Dot from A to O, there's no horizontal movement, so 0, and we're going down minus 26 over 3 units. So the dot product will be minus 5 times 0 plus minus 12 times minus 26 over 3, and this is going to be 0 and plus 104. And we are going to do the same. We already know the component of vector AB. Dot vector BC is going from B to C, so the x component is plus 10, but there is no vertical movement, 0. Minus 5 times 10 plus minus 12 times 0, and this is 0, so minus 50 is the answer. Section 3, which is the final section, the graphs of function on the plane xy are shown below. So we basically have to find the values of A, B, and C. So we know the vertex and the y-intercept. From the y-intercept, we know that C is 5. Remember the formula for finding the x-coordinate of the vertex, minus b over 2a. we can use this formula later. And let's substitute x equals minus 2 and y equals 1. And now we can go back to this formula, and we know the x-coordinate of the vertex, minus 2. And we can solve for minus b. So we now know a is 1, and we can substitute a equals 1 into this one to get the value of b. And b is 4. Number 2, because we have a straight line, we know that a must be 0, and based on the y-intercept, we know that c is equal to 9. To go from here to here, we are going 3 steps to the right and 9 steps upwards. So the slope is 9 over 3, which is equal to 3. So b must be 3. And the last question, we have a quadratic function again, but this time it's facing downwards, and from the y-intercept we know that c is equal to 6. And based on these roots, we can use the following formulae. One root plus the other root is equal to minus b over a, and one root times the other root is c over a. We already know c is equal to 6. So let's start with the product. Minus 1 times 3 is 6 over a. So minus 3 equals 6 over a, which means that a is minus 2. Minus 1 plus 3 is minus b over minus 2. Minus 1 plus 3 is 2, and b over 2, which means b must be positive 4. And that was it. Let me know if you have any further questions or comments.